Hello and welcome to Create the Future, a podcast brought to you by the Queen Elizabeth Prize for Engineering. My guest on the podcast this week is an author and broadcaster, well known to TV for presenting documentaries and to radio for his Life Scientific series. Jim Al-Khalili's main job, however, is as Professor of Physics at the University of Surrey. Having said that, he's also co-director of the Leverhulme Doctoral Training Centre for Quantum Biology and here's the connection to Create the Future, a judge for the Queen Elizabeth Prize for Engineering. So naturally, I have to begin, Jim, by asking how, as a physicist, you became one of the judges.
Well, my ex-Vice-Chancellor, Professor Sir Christopher Snowdon, became the chair of the judging panel. And so I knew him very well. We'd worked together and he'd invited me onto the panel as, I guess, the only non-engineer.
How did that feel then? Did you feel a little bit of a fraud, or did you think, well, no, actually, I've got something to contribute?
No, I didn't feel like a fraud. I know that my good friend Brian Cox was a judge on the panel when the prize was first set up a few years ago. So I knew I wasn't sort of, unique in this sense. But also, I think it's encouraging that, science, physics in particular, and engineering overlap in so many ways that I felt I could maybe bring a slightly different, sort of less applied perspective when judging some of the great contributions of engineering.
And I mean, that's true. I was probably a bit cruel calling you a fraud.
No offence taken.
Oh, good. Just as well. And, you mentioned this connection between particularly physics, but it's a lot of science and engineering. And it seems as though that's been one of the benefits of having this prize, is that people are seeing engineering in a different light, that they're seeing it encompasses or is attached to or works with perhaps far more areas than previously thought.
I think science it has its prizes. There's the Nobel, there's plenty of other prizes. Engineering has suffered from sort of an image problem. People often say, where are the superstars of engineering? If your average person thinks of an engineer as the guy who comes to fit their boiler, or someone with a hard hat on a building site, and it's always white and it's always a male, and so on and so forth. So I think engineering really needed something to boost its profile, to celebrate the superstars, and also to show that all these great scientific discoveries that we might make, scientists are essentially people who want to know the hows and whys, to understand how the world works. Engineers put that knowledge into practice. It's the next step, and it's no less valuable. So I think it's hugely important that some of these great minds in engineering, sort of applied science in a sense, needed to be celebrated in some way, and this prize is doing exactly that.
Now, the most recent prize was awarded to those who had played crucial roles within GPS. This is an area that sort of nicely overlaps with physics because it encompassed both physics and engineering.
Yes, for me, what was fascinating isn't so much the software computing developments or the technical know-how of how to get these satellites up there, how they communicate. It's a rather sort of nerdy point about how they maintain very accurate timekeeping, because that's where the great physics innovation comes in. These satellites that help us locate our position on the ground. Everyone who has a smartphone uses GPS on it to find their way around, which I'm sure you did in finding your way here to this office on Surrey campus.
Took a while.
But we take it for granted, how it works. And some people say, I don't like using GPS because I'm sending signals to tell everyone where I am. No, it doesn't work. It works the other way around. It's satellites sending signals to your phone, and you use that to triangulate. But the physics comes in because all these satellites have highly accurate timekeepers, atomic clocks, which are accurate to tiny, tiny fractions of a second. But because of Einstein's theory of relativity, which is, how I got all enthusiastic about this development, tells us that time runs at different rates. And satellites, because they're further away from the Earth, they're in free fall, in orbit around the Earth, their clocks run faster than clocks on the surface of the Earth. So the engineers learning this lesson from physics that time runs at different rates, have to deliberately slow down the clocks on GPS satellites in order for them to synchronize with time on Earth, because you need the time to be synchronized to work out how far away they are. Otherwise, we wouldn't find our position.
And I noticed on the way up to your office here that reception said there was an engineering department. So you've sort of got your physics and your engineering in the same building part of it here.
Absolutely. I mean, physics and in particular, electrical and mechanical engineering really, really overlap. An undergraduate student in the physics department or in the electronic engineering department would pretty much be doing very similar modules. So, they've got to do sort of the mechanics and the maths and the computing and electromagnetism, all the things that I think of as physics subjects. An engineer has to study as well. So we are part of one faculty, the physical sciences, together with chemistry, aeronautical engineering, and so on. And it's quite remarkable just how much these subjects overlap and the boundaries are blurred. And then when you graduate from university, very often a physicist will go and work in an engineering job, or an engineer will be doing a physics job.
And that you're next door to Surrey Space Centre as well, which is, what a success story for the university.
Yes, Surrey Space Centre, Surrey Satellites is a spin-off company, and I guess it's one of the things that the University of Surrey is best known for. For years, we were, along with, as was then Marconi's, we were the only institution in the UK building its own micro-satellites. And so these are washing machine-sized satellites, that companies put in orbit for all sorts of telecommunication applications. And so successful was the research here at Surrey that there was this spin-off company. My colleague Sir Martin Sweeting was very successful. And we still have this connection now with this company, Surrey Satellites, and the Surrey Space Centre, which is part, again, of our faculty. And it shows how a lot of these ideas are being developed in a university, then apply in industry and benefiting humanity rather than just learning more.
And this is an important part as well of the prize, is its beneficial impact. It's not just about innovation. It's also about how it's changed the world. I mean, is that a deliberate approach so that people can see this connection between something that may seem very other to people that actually know it's made your life better?
Yeah, I think that's vitally important. It's highlighting the fact that what many people would just take for granted is based on innovative ideas, very clever people thinking very hard and working very hard, that has completely transformed society, transformed our world. And, when we're going through as judges, looking at the different applications and nominations for the prize, we are, and we should know this stuff, but we are blown away by, oh my God, yes, that, billions of people wouldn't be able to do such and such were it not for this development. So it is very much about highlighting just how useful a lot of these applications are. I tell you a story which I've told many times. My son David, who's now in his late 20s, 10 years ago, when he was thinking about what degree to do, he very smart, maths and physics, A-levels and so on, and I sort of assumed he'd follow my footsteps into physics. But he said in the end, no, he was going to do electronic engineering, and that's in the end what he did. He went to Southampton to do electronic engineering. And his rationale was, Dad, you can do the deep thinking, I want to do something useful. Which is sort of a sweet distinction between physics, which is about wanting to know the hows and whys, and engineering, which is putting that knowledge to some use in society. That's
so funny, because I studied physics and my son is now studying engineering, and we thought maybe it's because his father did biology that he chose something in between, but actually I am the least practical person. I can understand easily how the machine we're recording on is working. That's not a problem for me. But actually, we're lucky we're recording this, quite frankly. That's all I can
It's on
say.
record.
Yes. There is a big thing. And it's lovely to celebrate the way engineers think, because you're right. It's a huge thing of maths and physics, or it could be biology if you want to be a bioengineer. But there is that ability to create something and to make something. And I know the problem-solving aspect is the same as science, because obviously you work in theoretical physics.
Yeah, I mean, it is all about problem solving in the end. It's a puzzle. How do I get this to work? And for me, how do I get this equation to work? How do I solve this integral? How do I get this computer program to model a particular system? But it's really no different in terms of an engineer faced with an instrument or a piece of hardware, and how do I get this to do this? It's about logic. It's about thinking logically and solving problems. So in that sense, it's very, very overlapping skills.
I mean, this is partly why I do broadcasting, and not my first job actually was as the equivalent of a sound engineer for the BBC, and it soon became apparent that again, the sort of the theory, yes, the practical, maybe not so much.
I decided to pursue theoretical physics rather than experimental physics when, as an undergraduate student, I almost electrocuted myself. I was cleaning some vacuum chamber in an experiment in a lab, and I had to clean these electrodes, and then realized after I'd finished that I hadn't unplugged it. And I could have been frazzled with several thousand volts. And I think I could almost imagine at that point thinking, you know what, I'm not cut out for this. I'm much safer on a blackboard with equations or in front of a computer screen.
So what are you most interested in working at the moment? I know that because you've written a lot about quantum mechanics, which is actually quite a difficult subject to get most people's heads around.
It is difficult, and I guess that's why I love it. You know, it's a constant puzzle. Yes, my main research area has been, throughout my career, nuclear physics. And of course, that doesn't mean nuclear power or nuclear weapons, but understanding how the atomic nucleus is built up of subatomic particles, protons and neutrons. So that all uses the maths of quantum mechanics. But of course, quantum mechanics is this weird counterintuitive idea of things being in two places at once, you know, cats in boxes dead and alive at the same time. The popular science, popularized version of it is well known. I've recently moved into an area where I'm applying quantum mechanics in biology. So we've now got a research center here at Surrey on quantum biology, which is a new research area. It brings physicists, chemists, and biologists together, and it's based on this idea that inside living cells, there seem to be certain things that go on that you cannot explain without appealing to the counterintuitive world of quantum mechanics. It's still controversial, you know, and mainly because physicists find biology difficult and messy. Biologists find quantum mechanics and the maths too complicated. And the chemists who are sort of stuck in the middle say, what's all the fuss about? You don't go around inventing new fields, which you're just doing chemistry. So, but it is exciting, and it's really allowed me now to move sideways in my research and actually develop some of ideas that I've had a passion for throughout my career on the basic foundational questions of quantum mechanics. What does it all mean? How does it happen? So I guess I'm more research active now than I've been for about 15, 20 years, which is nice.
Quantum biology is obviously very theoretical at the moment, but do you envisage a future where that could involve engineering?
Absolutely. I mean, I think even if the more speculative ideas that we're pursuing in our research in quantum biology don't come to fruition, there is going to be a convergence, I think, of several areas that are of interest now. So on the one hand, you have nanotechnology, developing sort of mechanical devices down at the nanoscale, a billionth of a meter. So these are the sort of size of, manipulating molecules. You also have synthetic biology, developing instrumentation which relies on the machinery of life itself. You also have quantum technologies, people who are working on developing quantum sensors, quantum computers, and so on. And you can imagine the convergence of all these coming together in some sort of, I'm trying to think of the right name for it. I don't have a name that trips off the tongue, but how about something like quantum bioengineering, right? QBE, right? If let's say, if I put it on record now, if that does become the name,
trademark it.
I'm going to trademark it. I invented it. But something like that, doing engineering down at the tiniest microscopic scales, engineering down at the level of molecules, is absolutely, I'm convinced, going to transform our lives in the coming decades.
Yeah, so it's a good example, I suppose, of how the profession is changing and evolving to incorporate everything new that we're discovering.
I think that's something we're seeing a lot in research, both within sort of industry and academia in universities. We are much more comfortable crossing discipline boundaries and coming up with these interdisciplinary, multidisciplinary research centres. So you're basically bringing people in with expertise from different areas, breaking down these silos, and looking at solving problems from different perspectives. I mean, it's easy to say, and it sounds really logical and sensible, but it is actually happening. And in our quantum biology centre, for example, we have PhD students who are have backgrounds in biology, who are teaching the physicists genetics, and the physicists are teaching the biologists about quantum mechanics, and it's exciting because you're starting to look at problems from a different perspective, and I think that is only going to get stronger and more prevalent within research.
And it must be nice as well when you're crossing disciplines like that to see all the different entries that come in for the Queen Elizabeth Prize. It's pretty impressive.
Yeah. I mean, looking at them, any one of the topics could so easily be the winner, and you can make a case for it. And sometimes it's down to, is the time right? It's not about how many billions of pounds or dollars has this industry, is it worth based on this innovation? So it's more about how the judges come to a conclusion that this now is the time is right to celebrate this particular innovation, this particular technology. But yeah, I mean, I sort of hope, I wish we could give the prize much more regularly, because there's a whole backlog of innovations and inventions and discoveries that somehow need to be celebrated in some way.
Now, the window for launch nominations takes place in April. What would you do to encourage people to apply, or are you finding that actually now, since it's been up and running, that it's not an issue, people are just going to submit entries fairly easily?
I think the prize now has developed a very high profile in terms of the coverage that it's received so far. People are aware of it. People are now talking about the Queen Elizabeth Prize as the Nobel Prize for Engineering. Depending on whether people say, well, we don't want to, we are our own prize, we don't want to be sort of be compared with the Nobel. But in terms of the wider society, everyone's heard of the Nobel Prize, but that doesn't cover all disciplines in science and engineering. This is the equivalent of that in terms of prestige, and so I think the profile is such that people are aware that this is something that they would love to be able to win. And so I can't imagine there's going to be any shortage of nominations put forward going into the future. Sometimes there are ideas, I think, that or innovations that we so take for granted because they are so part of our everyday life. It doesn't occur to us to dig back and find out what actually made them possible in the first place, because they are so ubiquitous. And I think somehow that's where a lot of engineering innovations suffer, because we so take them for granted, we don't realise the geniuses that actually allowed that to happen in the first place.
I've just realised, of course, that the comparison that does happen between the Nobel and the Queen Elizabeth Prize for Engineering, in that there has been an overlap with one of the previous judges, Frances Arnold, won the Nobel Prize for Chemistry. That's
right. Frances was one of the judges. In fact, she was a judge on the prize the year before I joined. So I met her briefly, and that was just before she won the Nobel Prize. Otherwise, I'd have been even more in awe of her. She is an absolutely remarkable woman, and of course, what makes her even more remarkable is that she had submitted some research recently, which she then had to retract because some issues showing the honesty that in science that you can make mistakes and that's fine and that's how you learn. So yes, she is an absolutely remarkable woman.
Now, this is not necessarily an easy question to get people to answer on the spot, but for you, which engineering innovation has probably had the biggest impact on your life, be it professional or personal?
Wow, that's really, really hard to say. I mean, in computer science, I guess computers are so ubiquitous that we don't know how we would live without them, and the internet and the World Wide Web. I don't want to really go there because, of course, the World Wide Web was invented by a physicist, and we're celebrating engineering here.
But they did win the Queen Elizabeth Prize for Engineering because of all the computer engineering and software engineering that went on.
Exactly, absolutely. So software engineering certainly is something that has transformed society in my lifetime. But this is the problem that, you look at all the different technological aspects that surround us in our everyday life, and you can pick any one of them and dig back and realize that wouldn't have been possible were it not for this engineer here or that engineer there. So, it's really hard to disentangle, where, I can just look around and just pick up my smartphone and look at the technology that goes into that, whether it's material science, whether it's electronics, computer science, so many innovations. In a sense, because engineering tends to sort of span a lot of disciplines, it's quite hard. It's harder than the Nobel, where you can go and say, well, so-and-so discovered this enzyme, or so-and-so developed this equation in physics. In engineering, because it brings together so much expertise, it's really hard to draw boundaries or encapsulate, prize for one thing. But, we just keep on trying to celebrate the best that we can.
Jim Al-Khalili, thank you very much indeed.